Welcome back. So let's continue. Today we will use and understand the concept of a tool named linear directional mean. So it's a part of this measuring geographic distribution, which is part of this, which is a part of the large tool set within this ArcMap, which is designed to analyze geographic and spatial patterns of the GIS data. So the directional trend of linear objects is calculated using a different methodology from points or polygons. The lines are analyzed to determine their angles, and then the mean angle is calculated. The result demonstrates the directional mean as an arrow. So calculating the linear directional mean can result in one of two outputs depending on the input data. The outputs are the mean direction and the mean orientation. Each result is based on the average angle of the lines in the dataset, but mean direction takes into account the direction of movement. So the mean direction is useful for data that represents features that move, such as hurricanes or wildfire. So the result of the linear directional mean tool are in the will be displayed using an arrow to show the direction. If the line features represent stationary items such as fault lines or freeway systems, they do not have direction. Instead, the line created by this tool, the linear directional mean, will show only the orientation. So in our case, we have this data for a certain region. So the red dots represent the tornado touchdowns. This is a population of the area. So this darker purple colors show the high population, light is smaller population, and we see this tornado breakdowns, touchdowns. So we can see the attribute table, so it shows year. So see that tornado touchdowns happen in different years, longitude and latitude. So also fatalities here, injuries, Fujita scale, which shows the scale of a tornado, where 1 is this not very strong tornado and the 5 is the strongest tornado. But in this case, the largest one is 3. So, and this is a tornado storm track. We can see here that they are connected. So also the year here, the same fatalities, injuries, Fujita scale, and it's in polyline, you can see here. So let's zoom and see that this is a tornado touchdowns I selected. So from general, we can see here that these are the different touchdowns, but these are for the same year. So see that fatalities, injuries, dollar, so they have different Fujita scale. So tornado can change its scale also by time. So, and this is a storm track. So how the tornado moved. We can select this one as well. See, yeah, 1955, the past 5 fatalities, injuries, Fujita scale, etc. So unselect, and let's find this linear directional mean. This is in spatial statistics toolset. So all the tools I was using in previous videos as well is related to the spatial statistics. So let's have a fast glance on it, have a fast look. Identifies the mean direction, lengths, and geographic center for a set of lines. So these are a set of lines input, and as an output we will see this mean direction and mean length and geographic center of this set of lines. So this is a mean direction. So in general they're looking to the same direction, but except this one probably. Mean lengths, they might have different lengths, and geographic center somewhere here of a set of lines. So we will this is a mean directional. This feature, by the way, input feature tool works for this lines. So if standard instance and previous tools that we worked, and the case field will be the year. Case field used to group features for separate directional mean calculations. The case field can be of integer, date, or string types. So this is in this case integer. Let's compute. So it has been created. So let's change the color to the yellow one. So see, we can also go to the properties and see the years as well. Go to labels, check label features in this layer, label field, year, and change the font size to 28, for instance. You can make it bold. So see that it shows the mean direction, linear directional mean for each year. We can go to this year, to the file. Let's see for 1995. So we can go to storm track, for instance, and let's choose this select by attributes and search for a year to see, for instance, to check for 1977. See that there are four lines have been selected. Can just see that for 1997 four lines, but where is the 1997 here? Yeah, this is 1997. Where is it? Yeah, this one is 1997. Direction. Meanwhile, if we'll choose from here, for instance, using select attributes, which storm segments, storm track have been applied for this to find this linear directional mean for 1997. These storms have occurred, tornadoes occurred in 1977. Four storms, tornado types, here, 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 and here. And this linear directional mean for 1997 was here. So it shows the mean length from all of this. This is a mean length. So see that is shorter than this, but taller, longer than this. Two storm tracks. Also, it shows the mean geographic location. So compared to all this, this is a mean geographic location and the mean direction as well. So it can be helpful for many real life applications. For instance, police department can make the track from the point a car is stolen to the point of the recovery. The results give a directional mean that can help predict the actions of an auto theft ring. Or for instance, wildlife biologists use animal tracking data to map migration paths. The linear directional mean of those These passes may give some insights into why certain passes are chosen or highlight the need for protected habitat, etc. So you can see that it is useful tool. We can go to spatial statistics. See that many tools we have been already created. Standard distance, mean center, median center, linear directional, mean central feature, directional distribution, which is directional, the deviational ellipse. So all this measuring within this part of this measuring geographic distribution, all these tools are very helpful and very useful in measuring the geographic distribution.